Hello and welcome to our lesson on section 4C, the laws of logarithms. So the laws of logarithms are something you might remember from your grade 11 university class that you took in grade 10. If A and B are both positive, then these are three rules that apply for logarithms that we can use to take a long expression and simplify it to a shorter one, or take a shorter logarithmic expression and expand it to a longer one. What's important to remember is that logs must have the same base to apply the laws of logarithms. So first, if I'm adding two logs with the same base, I can keep the log in the base and multiply the two values. If I'm subtracting two logs with the same base, then I can keep the log and the base and divide the two values. And if I have a factor times a log of a base, I can bring that factor up like an exponent. So this is the most useful log law because it helps us get a variable out of the exponent as well. Remember that these log laws can be used heading towards the right, but they can also be used backwards if you want, from something simpler to expand to something more complex. So we often use this one in reverse. We can use these laws to simplify logarithmic expressions and to write as a single logarithm, and that is helpful if we want to solve the logarithm. So for example, if I want to write these two as a single logarithm, I'm going to apply this third law first, okay? So the first thing I'm going to do is I'm going to say, okay, this is the same as saying log base 10. Remember that if there's no base written, it's assumed to be 10. So log base 10 of 2 to the 5. I can take this factor and bring it up as an exponent. Then I've got two logs. They both have the same base, 10. So I can keep the base and I can multiply the two values together to get 2 to the 5, which is 32, times 3, which is 96. So it's the same as the log of 96. For this one here, I can expand these rules to more than just two terms. I'm going to start by keeping the base, keeping log base 10, and I'm going to multiply the values together. 4/3 times 3 times 7. Those 3's cancel out and leave me with log of 28. And I can evaluate that on my calculator if I need to. Last, if I have log 8 over log 2, remember that this is not the same as this situation. Okay, that's the log of two values being divided, not two logs being divided. So what I need to do is rewrite this in terms of the same base. And then I'll notice a little trick here. When I rewrite this as log base 10 of 2 cubed, I can drop that 3 in front, and all of a sudden now I have 3 times log 2 over log 2. Those log 2's can cancel out, and I'm left with 3. A couple more examples. If I wanted to show that, IB sometimes likes to ask you questions to show that something is true, I'm going to do a left side, right side proof. So I'm going to set up the left side as log of 1/8, and the right side is -3 log 2. I'm going to start by rewriting this by taking this factor and moving it to the exponent using my log laws. Then I can say that 2 to the -3 is 1 over 2 cubed, or 1 over 8. So that is the same as the left side, and therefore my proof is done. Another question that IB really likes to work with are these kind of arbitrary questions where they make different logs equal to different values, and they want you to rewrite this in terms of P and Q. Okay, now in the question I took this from in your book, they also had R, but we don't actually need R to rewrite this one. That's why I crossed it out. Okay, so first thing we have to do is we need to think about how could I rewrite 108 in terms of multiples of 2 and 3. And I got 3 cubed times 2 squared. How did I do that? Well, I thought about this. I said, okay, how could I rewrite 108? Well, it could be 9 times 12. 9 I can rewrite as 3 times 3, and 12 is 3 times 4, or 3 times 2 times 2. So now, in terms of 3's and 2's, this is 3 cubed times 2 squared. I'm trying to do a prime factorization there. Now, if I'm multiplying these together to get 108, I could also split the log and say log base b of 3 cubed plus log base b of 2 squared. I can drop